in long-term memory without any effort at all. So this is 1/2 theta r squared. But what's wrong with my theta? It's in degrees. So the first thing you're going to have to do is change your 90 into, and the degrees cancel. You get 90 over 180 pi, which is 1 or pi over 2, 1/2 pi, whatever you want to do. So this is going to be 1/2. My angle's pi over 2. And they told you, by the way, that this segment is 8. What is that? 64. And you got 64 because you squared the 8. So that's going to be pi over 4. Yes. Times 64. And that's going to be reduced 16 pi. That's the whole sector. The whole thing, the whole slice of pizza.
Use the person selector.
I will when I get to the lesson.
So, Bob, question.
Yes.
On the homework and stuff, section 10.6, right?
Yep. It's actually 10.6, 10.7 combo on notes. All right, how do I do the area of a triangle? It's going to be 1/2.
So where's 849.5? Is it in the book?
It's in the book on 10.6. See, I put section 10.6.
No, like the EOC.
The EOC, yeah. I'll show you. I'm going to show you. Okay, triangles, base times height, and the relationship between a base and height is perpendicular. The base of my triangle is definitely 8. Now, this is another skill you're going to need for the rest of this unit. What's a segment called that extends from the center to the circle? A radius. I have another segment that starts at the center and goes to the circle. What is it? All right, you had to recognize that that was a radius, and that's also 8. So what's the height?
8.
So 8 times 8 is 64, divided by 2 is 32. Now right, so we're going to have 64 over 2, and what's 64 over 2? 32. Now, remember we talked about we have to take the entire yellow region, which is 16 pi, and then we want to subtract from it this triangle, which happened to be what? 32 pi, and that leaves that yellow half moon. And that's not a pi, it's just 32.
Wait, Ms. Carter,
Yes?
for the original, just the A degree, why did you multiply the denominators?
Because when you multiply fractions, you multiply numerator times numerator, denominator times denominator. In add and subtract, we get common denominators, and then we don't touch them. But in multiply, we multiply them. Yeah, I would leave this as 16 pi minus 32. Yeah, you could use your calculator, but I'm too lazy to get up and get it. I know it. All right, so someone asked me to do 14, which you cannot see, but I at least can see. 14 again was area of a sector, and this time it's really similar to what we just did in the fact that they gave us a box. This is 14 on 10.7, and they told us this was 16. Nathan, you're the one that asked for 14. What does this box mean? 90 degrees. So what do you have to, we're looking for the area of the sector. What's your formula? Formula. R squared. And what do you have to do to 90? And we're going to get 90 over 180 pi, which is what? 1/2. So I've got 1/2. I've got 1/2 pi. What's our R? Now, there were some questions before school, and what we do first in order of operations. Exponents. So I can't multiply 16 by any of this until it gets squared, and that's 256. 1 times 1 times pi, 2 times 2. Right, and that divides. That's going to be 64 pi. All right, then someone wanted one from 10.6, which was arc length. No, someone asked for 10.6. All right, so I don't know which one you want from arc length on 10.6, but I'm going to pick one. This is a this is a diameter, and they're telling us that this is 60. This is 60, but we want the length of this arc. This is number 31, and they told us that this is 24. So the arc I have has no measure, and I do not have a radius. I have nothing that I need. How do I get the measure of this arc? It's going to be 180, and I'm going to need to see this work on tonight's homework because that's about all the work you're going to have, and that's going to be 120 degrees. So this is 120 degrees. What's my radius? 12. So with that, this is arc length. So that means it's going to be L is equal to theta times R. Is my theta in the correct form? Yes. Uh-huh. What lines? That's my diameter. And that was my, yeah. And I had to have this as a diameter so you knew that was 180. Without the diameter, you wouldn't have known. So we're going to do pi over 180 degrees, which gives me 120 over 180 pi, which definitely simplifies to 12/18. 6 divides 12 and 6 divides 18. So you're going to have 2/3 pi times your radius, which is 12. And when you get 24 over 3, you will have 8 pi. On tonight's homework. This is more like tonight's homework. You'll see. All right. What? I'm confused. All right. You asked about... Shh. Quiet. Then you must have done something wrong. No, because 60-degree arc length is not going to be the same as the 120. All right, this is question 1. This is, sorry I didn't number it. I don't think so. Oh, you will. Okay, number 1. So on number 1, and this, you're going to have this more often because I did this a lot, all right? So it says state with justification everything that's true about angle 1. So we have angle 1. What's one thing you know about angle 1? It's vertical to 4, meaning angle 1 is congruent to angle 4. And the justification is vertical angles are congruent or are equal. All right. There are parallel lines. Now, did I tell you this was 90? Did I tell you anything here was 90? So can you assume 90? Now, if I had told you this was 90, 1 and 2 are complementary, but we can't go there. Do you see those arrows? That's parallel. What's corresponding to 1?
4.
Okay, now remember, you have to form an F.
It is.
4.
If I were to...
Oh, never mind. I thought angle 1.
What is corresponding to 1? All right. It has to make it the letter F. Okay, here's angle 1. Okay, and now we're going to come down here to 7. I don't think that's an F. That is a bent F. We never had bent Fs before. It's going to be angle 9. Okay, do you see the F? So, angle 1 you know is congruent to angle 9. Why? If lines are parallel, corresponding angles are congruent. Now, 1 is not in between, so there's no way 1 can form a Z, and there's no way 1 can form a U. But there is...
1 and 13. 1 and 2 or something, right?
What is alternate exterior with 1?
1 and 13, right?
4.
Not 1 and 13.
11.
1 and 11.
There we go.
1 and 11 are alternate exterior, and then you'd have to justify.
Wait, so 1 and 9 are corresponding?
Now, do you agree 1 equals 9?
Yeah.
What's the relationship between 9 and 10?
They're linear.
Meaning they equal 180. So if 1 equals 9, what's the relationship between 1 and 10? They're not linear, they are supplementary. We already went there. Linear, no, but linear means they're attached on a line, and 1 and 10 aren't attached on a line. Okay, you're losing that part. 1 is supplementary with angles 2 and 3. Okay? 1 would be supplementary with what angles? 6 and 5. So that was what you were supposed to do on 1. On 2, you're drawing a triangle. How many angles are in the triangle? 3. So how many bisectors, constructions with compass straight edge are you going to be doing? 3. So if you have an angle, how do you do the angle bisector? Yes, but I'm just doing one angle bisector. They didn't know how to do that. So what we're going to do, you're going to put the compass point on the vertex. You're going to open it up. Now where do you put your compass point? So we're going to move the compass point over here, and we're going to do an arc. And then we're going to move the compass point up here. And we're going to do, oh, I just moved it. Are you sure? Then we do another arc, and then what do? From here, that's an angle bisector. Now you're going to draw a triangle, and how many are you going to do of those? 3. What does a perpendicular bisector look like?
Wait, Miss Bride, I have a question. Can you just go from the first point, like the origin, and just do that?
What do you mean, or you mean the vertex?
Vertex, yeah.
I started at the vertex to make the first arc. No, because you need it from equidistant from the sides. Yes, you draw your own. It just says draw triangle paw. BAJ from where? Is it a triangle? I will look at it in a minute. All right. Perpendicular bisector. 2 and 3 are going to be credited to A49.5 tonight's homework. Number 1 is going to be credited to A49. Well, I just need to be able to see it on Monday. No, this is not the Cyclops. This is the fish. So you put your compass point on one end point. This has got to be open over half. You do a nice big arc. We're going to come over here. So you're going to put your compass point here. It's not on it?
No, it looks nothing like the Jesus. I didn't know the Jesus fish had two.
All right. Quiet. All right. Now, again, you're supposed to draw a triangle, and you're supposed to bisect each side. Okay? Bisect each side. So that means you'll do 3 of those. Now, if you make your triangle really, really tiny, it's going to be really, really hard to see what you're doing.
You just do it like if this is the triangle, then you do it there.
There, and
Alright.
So my suggestion is that you draw a relatively large triangle in order to make that easy.
So I have 1.
Give me a minute.
Are you returning NA49?
All right. So this is starting the next piece of the last piece of our unit 3. When we're now transitioning totally into degrees. That's why I'm doing a test on radian measure, because that's a good place to stop. Arc of a circle is 2 points on the circle and the continuous part of the circle between the 2 points. The 2 points are called the endpoints of the, not circle, but endpoints of the arc.
You want us to write all that down?
You could have printed the notes and it would have been printed. You could print it tonight. You just need to know that an arc contains two endpoints and the part of the circle that's basically in between. You have been working with arcs for about a week, okay? But this is its formal definition.
Why do you, like, instead of doing all that, why don't you make it, like, just how you
He's questioning you.
Like, you just said basically all you have to write is an arc has two endpoints, and it...
Well, because it needs to make, there needs to be some mathematical correctness there. And then I'll give you the layman's terms. Okay, types of arcs. There's three types of arcs. Semicircle is an arc of a circle whose endpoints are the endpoints of a diameter. And you all have recognized semicircles in the past. A minor arc is an arc of a circle that's smaller than a semicircle. So probably the most important piece is the type of arcs, if you have to take notes, which you should be. All right, we all know that the measure of a semicircle is what? 180 degrees. So everything's going to be compared to your semicircle. So you can either equal 180, or be less than 180, or be bigger than 180. So a minor arc, if it's smaller than a semicircle, means that its measure is less than 180. Now, a minor arc and minor arcs only are named with the endpoints and an arc symbol above. So if I talk about arc AB, I'm talking about a minor arc, an arc that's smaller than a semicircle. So this would be arc AB because it's smaller than a semicircle. Because a semicircle is going to have endpoints of a diameter, and that's not as, you with me? It's all based on, you were comparing everything to a semicircle. So if a minor arc is smaller than a semicircle, then a major arc is larger than a semicircle. Semicircles and major arcs are named with 3 letters. 3 letters, really important. Minor arcs are the only ones with 2. Yes?
I have a question. So a major arc is an arc of a circle that is larger than a semicircle. So that means it's more than 180.
Correct.
But then on minor arc, you put measure is greater than.
That's less than.
Less than 180.
That's a less than sign. This measure, if I use the same, this measure is greater than 180. That's the greater sign.
Oh, okay.
Okay, that's all right. Now, 3 letters. So if I have letters A, B, C with an arc symbol above, the end letters would be A and C, are going to be the end points. And the letter in the middle is a point that the arc passes through. So I've given you an example of a major arc. Part of your homework is just doing major, minor, and identifying them. Or write the arcs. So A starts at A, stops at Y, passes through M. A, M, Y is a major arc.
Wait, that's it?
Yeah. Now, if I want a semicircle is also using 3 letters. Ethan.
How do you know it's not M-Y-A?
And it says Amy.
M-Y-A. Oh, how do we know? Because it starts at A and it stops at Y. M-Y-A would start at M and stop at A. Well, but if we want to talk about this arc, Trevor, then the A and the Y are on the ends. It's going to be real important to identify. They will probably give you this and ask you if it's a major or minor arc. Or they may ask you just to name a major or minor arc.
That's fine. And we know it's A-M-Y instead of Y-M-A because, like, alphabetical order.
Oh, no. Y MA is the exact same arc because the endpoints are the same and they pass through this. Okay, that's important. Those are the same arc. All right, here's a center. This is a semicircle. If this is AWP, then this semicircle up here would be arc AWP. If you just say AP, you don't know if you're talking about the upper one or the lower one. So anything equal to or bigger than 180 is going to require 3 letters. Congruent arcs are arcs with equal measure. Just like segments are segments with equal measure. Angles are angles with equal measures. Congruent arcs are arcs with equal measures. All right, our next piece, if we want to, I'm going to go through a couple minor arcs. Arc AG is minor. Arc GC is minor because AFW is a semicircle. So I know arc BC is minor. I know that arc CE is minor. Lots of them. If I want a semicircle, there's 2 choices. The one at the top, which starts at A, ends at W, and passes either through G, B, or C, your choice. And then there's the one underneath that starts at A, stops at W, but either passes through E or D, your choice.
Wait,
Raise your hand if you have a question, Brian. Okay, Brian brought up a good point. He's talking about the arc from C to G. If I go from C to G this way, it is not minor, it's major, and it requires 3 letters. See why we need 3 versus 2? Otherwise you get confused. Yes?
How is ABW?
A, W are the endpoints, and it passes through B. That is a semicircle. Wendy?
Do you have like GAE or EAG and can it?
GAE is a minor arc. We do not use 3 letters.
Wait, you can have 3 letters for a minor arc?
No.
Then why would that be a minor arc if you say 3?
GAE is less than 180.
Did you want to say
Where are you guys getting GA?
So GAE doesn't exist.
GAE is not a major arc. It's a minor arc. We call that GE. Okay? Major arcs. Arc E, B, C is 1. Arc D, E, B is 1. Arc A, C, D. There's lots of them.
It's going to be on our next test.
Because when, not this coming up, but the one after that.
Oh.
All right, because we start at A, we stop at D, we pass through C. So it's going way beyond a semicircle. Okay? All right, another key piece here. What? Does he? A major arc and a semicircle are not equal because a semicircle is exactly 180 and this has to be bigger than 180. But they both use 3 letters to be named. Yes. Okay, so now we got to talk about a central angle. This is important. A central angle is an angle with its vertex on the center. Bless you. Think about this. Central, center. Central angle, vertex is on the center. And in degrees, the measure of a minor arc, any minor arc, is equal to the measure of its central angle. So if I told you that angle GFA was 28 degrees, that means the arc it cuts off is 28 degrees. If I tell you that angle angle AED, this angle right here is 9x minus 13, and I tell you that this arc right here is 7x plus 21, central angle equals its arc. That means 9x minus 13 equals 7x plus 21.
Okay, got it.
Central angle equals its arc. So we're back into some of the algebra. Now, if you listen to period 1 notes, I had time to finish working that problem. Bless you. Okay. This, yeah, I think you might only have one algebra. If we look at angle AEH, I'm sorry, this should be angle AFH. Angle AFH, it's a semicircle, so what does 5x minus 13 equal?
Wait, couldn't AEH be
180 degrees.
Oh,
All right, so please listen even if you are packing up. Arc addition postulate. This is what a lot of your homework is, Nathan. The measure of the arc formed by two adjacent, meaning next to each other, arcs is the sum of the measures of the two arcs. It's like segment addition, but it's for angles. In other words, if this arc is 32 and this arc is 59, how do we get the arc from here to here? If you add, subtract, multiply, or divide, I better see work. If you want credit, I need to see 32 plus 59 is equal to 91. But let's look at the other one. If I tell you that arc TW is 89 degrees, arc TW is this whole thing, 89, and I tell you that TE is 44, how do I get the measure of this angle? I find the measure of that arc. And now what's required here? 89 minus 44 is going to give me an arc of 45. And if my arc of 45 is going to equal my angle there. All right. I'm going to post both periods. My voice just isn't as loud.